Hello everybody, my name is Alessio Bolognesi. I work for Federunacoma, the Italian Federation of Agricultural Machinery Manufacturers. And first of all, let me thanks for the invitation, and I'm very pleased to be here to talk to this wonderful audience. I try today to speak a little bit about the future of our water industry, which is to me in robotics and AI. First of all, a brief presentation. Again, I'm working for Federunacoma and I'm the technical officer for digital agriculture affairs in the Federation. Federunacoma has a history 80 years long, which is quite a lot. We have about 360 members distributed in seven associations, each of those dealing with different types of machines and products. And I'm personally the secretary of Agri-Digital Association. We have three offices around the world, well, in Rome, Bologna, and one in Brussels for the European and International Affairs. And we're proudly members of the boards of the SEMA, the European Association of Manufacturers, the Agriculture and Industry Electronic Foundation, EGMF, and Agri-Evolution, and others. And we are also the proud organizer of one of the most important trade shows of agricultural machineries around the world, EMA International, which is happening this year in November from 6th to 10th. But I'm here to talk about some technical topics. And to understand what we are facing in our future is, to me, very important to understand where we come from. And I will start from the 90s, the very important first milestone, which was the introduction of first electronic devices on agricultural machineries to perform more precise operations. And in the meanwhile, the industry started to develop the ISO 11783 standard, which was then friendly named ISOBUS. And along with that, we started to introduce later on the GNSS technology, so the Global Navigation Satellite System, and positioning then in the agricultural application. That allowed to start talking about precision agriculture, perform operation on a position based. But in the meanwhile, also another technology or another science was starting to become very important. It was the information technologies, because developers started to develop the first farm management information systems to gather information from those new sensors on the machine or the use of the machines, from the analysis of the ground and crops, and with agronomical expertise started to give some hint to the farmers how to perform better operation and to have more food and with a higher quality. But later on again, we started to talk about data and connectivity. Yeah, 4G came in the game, 5G now, Wi-Fi, and so on. We started to talk about cloud connectivity, data interchange, and we started really to talk about the digital agriculture, which is a wider, I would say, a wider process than the precision farming. I prefer to call it data-driven agriculture. So we started to have a huge amount of data, and in the meanwhile, the environment around the agricultural machinery changed. We had a huge computing power at an expensive cost. We had a broadband connectivity allowing us to share a huge amount of very high quality data. And this was the driver to introduce robotics and artificial intelligence in our sector and in many others as well. Why? Again, because those technologies are very, I would say, have a long heritage, but there were not the condition like broadband connectivity, data quality, computing power that we have today. And this is allowing us to really develop application based on those technologies. In the meanwhile, we have challenges risen around the world. The first is feeding people, By 2050, the FAO estimates that we are becoming 10 billion people in the world. So we have to feed all those peoples. Last but not least, this has to be done in a more sustainable way. Europe and all the other countries are working on sustainability of all the practices, including the agricultural ones. So we have challenges which are not really, how can I say, not really easy to meet all together. So we have to produce more food of a better quality in a healthy way for the food itself and for the environment. So we have to minimize the use of pesticides and chemicals, minimize the use of, or at least rationalize the use of water resources. We have in general to reduce the environmental risk and to reduce the carbon footprint of agricultural practices. And again, we are facing a very, very big problem, which is the lack of labor in the rural areas. We have no people for operations like picking, pruning, etc. So we need help to allow farmers to keep going with their food production. And this is why the industry today is trying to push to the limit the principle of precision agriculture, and like I mentioned, is going toward the digital agriculture. And we have to create value from data, and in the meanwhile create a safe environment for workers and operators. And again, in the meanwhile, we have to produce healthy food. We have a lot of means to do that. We have the real-time monitoring, analysis, and applications. We have localized and optimized applications. So with the positioning system we have and the new AI-based optics, we can, for example, operate on a single plant or leaf or area in the ground. We have to reduce the carbon footprint. We have to optimize the use of water, take care of the soil, etc. A lot of things we have to do in the same way. And in the meanwhile, like I mentioned, we have to find a solution to the lack of labor. And AI and robotics are really part of this solution. Here are a few examples of machines, robotic machines dealing with harvesting, dealing with weeding, and in the bottom one, which is a tool carrier. So it's basically a small tractors for vineyard and orchards, capable of bringing and using different tools like small tractors. But again, it's not just related to machines. So AI has a very important role in all those technologies to help creating models to recognize the fruits, recognize the branches of a tree that should be pruned, to recognize the drive path through the fields, etc. So AI and robotics are really strictly connected. I would like also to mention the digital twinning, but I would not like to give too much information and too much complexity to the discussion, because my focus is on another direction. All those technologies have to be used in the farms, which are becoming very complex systems. They have to deal with livestock, food production, livestock food production, taking care of the soil, all the things I already mentioned. And so we are talking about the circular economy of the farms today. But it's a really complex thing for a farmer, and maybe they have to be self-sufficient from an energetic point of view. And the farm itself is integrated in the agri-food chain, which is becoming very complex. We talk about recyclability, we talk about traceability, we talk about sustainability of every part of the agri-food chain. How can you do that? Through data information. The flow of data and information is the key factor to allow all of that. But we have, again, new challenges. If it's not enough, we have also authorities which are producing regulations, standards, and asking for certification to really prove that these practices are carried on. For example, I'll give you just a first hint of one of the discussions we are having on in this case on autonomous machines is about what is an autonomous tractor. We don't know so far because is that a traditional tractor, so with a cabin and whatsoever, capable to perform also autonomous driving operations? Well, it becomes in Europe to type approval and to it belongs to the tractor mother regulation. It needs to have an operator presence control. It has a lot of things that are really unrelated to the robotics. Is that the autonomous tractor we're talking about? Or maybe something without a cabin where the operator is not foreseen anywhere if not for a supervisory role. But this type of machines today belongs to the machinery directives. Has the machinery directive everything to cover those aspects and the safety of those machines? Not so far. No, so far. So we have critical aspects, or maybe the future is about very dedicated robotic machines to perform very specific operations. Again, they belong to the machinery directive, but is that enough? We need something more. Well, there's a lot of discussion ongoing. We have some first ideas, but I don't want to give you some answers today because we still don't have them. But just to give you some hints of the complexity of the discussion, and this is just one of those. Of course, there are regulations coming in Europe, for example, to deal with those new technologies. So the new machinery regulation, which is taking over the machinery directive and tackle some aspects of hardware, software, AIs, robotics, etc., for the essential health requirements. But it's not enough. We have the Artificial Intelligence Act, which deals with application and the risk related to application of AI. It's a horizontal theme, but includes also in the scope the agricultural machineries, and as well as the Cyber Resilience Act related to cybersecurity of data information and specifically with the cybersecurity of products put on the market. And we have the Data Act, which obliges the manufacturers to uh, deal with certain requirements when gathering, managing, and providing services on the data produced by their products. These are just a few of the upcoming ones. The scenarios and the new legislative framework is becoming very complex in Europe, but this is true all around the world. We have regulations and standard upcoming in Australia, in Japan, maybe in America and other areas, but the problem is that there's no alignment at all among those regulations and standards. In the meanwhile, those autonomous and AI based applications have to be integrated in the today's farm. Uh, and today, farm includes normal machines, include maybe other robots from other brands, includes humans, animals, other services, livestock. So we have to work in an integrated environment where the data interoperability is the key factor to have an effective production in the farm. So interoperability of data information and technologies is a must for our industry. And we're working very hard on that. We're working on the ISO level with new working groups dealing with the standards. I'm going to show you a couple of those later on. New standards related to those new technologies, both from an engineering and safety perspective. We're working very hard at a European standardization body to write harmonized standard to deal with those new topics. We're working very hard in new expert teams and project teams in the AF to deal with data security, with wireless in-field communication, to deal with autonomy. So all those aspects which are becoming key factors in our industry. And in the meanwhile, especially on a political level, we're working very hard with the European Association SEMA to bring some messages and some requirements and requests to the European Commission. And of course, we're trying to do that at also an international level because, like I mentioned before, we all have to work together. So, a couple of new results from this work. The first one the first one is the upcoming ISO 18497 standard dealing with the safety of partially automated, semi-autonomous, and autonomous machineries, as well as the new 24882 project, which is dealing with the cybersecurity aspects of agricultural machineries and products. But again, there are a lot of activities ongoing. I have not much time, so I'd like to close this speech with a brief message to all of you. I really think that technology, AI, robotics is part of the future of agriculture and is part of the future of our farmers. And the importance and the quality of data is really a key factor in this future. However, at the moment, we have more questions than answers. And a way to try to give some response to those questions is really to work together. We need the whole industry, including the new key players, so robotics and AI solution providers, work together to meet the common challenges and goals. With that, I'd like to thank you for the attention. I hope I met your expectations on this presentation, and I'm available to any question from your side. Thank you.